Hey everyone, sorry I'm not in class today. I decided to make you a video so you could still have instruction from your teacher, and I'll stick it on YouTube so you guys can watch it and fill out your notes. So, the first thing we're going to do is go over the bell work, and I know it looks crazy, it's stuff that you've never seen before, but I promise it won't be too bad. We're going to cover exponents thoroughly this week in bell work, okay? And so I'm going to show you the long way to do it first, and then I'll show you the trick. So Monday, column 1 says I can apply the multiplication property of exponents to generate an equivalent expression. So we know that 8 to the second power means 8 times 8. And 8 to the sixth power means 8 times 8 times 8 times 8 times 8 times 8. Right? So we know that 8 to the second times 8 to the sixth is 8 to the eighth, right? We have 8 eighths there, right? 2 here and 6 here. Okay, so we do division kind of the same way. If we have 3 to the fourth divided by 3 to the second, I'll go ahead and write it as a fraction. 3 to the fourth is 3 times 3 times 3 times 3. And 3 to the second is just 3 times 3. Okay, so we know that any time we have a number divided by itself, that's 1. So we can do 3 divided by 3 is 1. They cancel. And 3 divided by 3 is 1. Those cancel. So we have 3 times 3 left. So we'll write that as 3 to the second power. The third column says I can apply the exponential property of exponents to generate an equivalent expression. And I kind of showed you this in the textbook. If we have 9 squared 3 times, that's 9 squared raised to the third power. That means we have 9 times 9 3 times. So how many 9s do we have? We have 6. So I'll write it as 9 to the sixth power. Okay, so now I'll show you the trick. And the trick for your notes this week is kind of like PEMDAS. It's just something that helps you remember rules for exponents. And what we're going to call it is MADSEM. Okay, and you can think of MADSEM as if you're multiplying, you add the exponents. If you're dividing, you subtract the exponents. And if it's the exponential property, you multiply the exponents. So what does that mean? If we're multiplying, and in column 1, we're multiplying, right? So we'll use the MA portion of MADSEM. If you're multiplying, you add the exponents. 8 to the second times 8 to the sixth, you add the 2 and the 6, and that gives you 8 to the eighth. Okay, so MADSEM with the division property, that's the DS portion of MADSEM. That means if you're dividing, you subtract. So we're dividing 3 to the fourth by 3 to the second. We subtract 4 minus 2 and get 2. Okay, and exponential, the exponential property is the EM portion of MADSEM. If it's exponential, meaning a power to a power, you multiply the exponents. So 2 times 3 is 6. All right, so now that you know the tricks, you can go ahead and try to do the fourth column. We have 4 to the third raised to the power of 2 times 4 to the second divided by 4 to the third. Okay, so 4 to the third raised to the power of 2, if we're using the exponential property, that would be 4 to the sixth, times this 4 to the second. So times 4 to the second, it leaves us with 4 to the, well, isn't that the same thing as what we had in column 1? 4 to the eighth. Add the exponents. So we know the whole top simplifies to 4 to the eighth. And then to simplify 4 to the eighth divided by 4 cubed, right? We subtract and get 4 to the 5th. Okay, and we're going to be practicing that all week, so if you don't understand it today, that's okay. Write down your questions and I will answer them tomorrow. Okay, so now we're going to work on our notes. So hopefully the sub has passed out the notes. I'll zoom in a little so it's easier to see. So this is straight from your notes, and we are combining like terms officially, and it gives us a long statement here, a long expression, 9x minus 2 plus 16x plus 8 minus x plus 10. And it wants us to separate the terms into variable terms and constant terms. So variable terms, guys, math isn't too tricky here, means the terms with a variable, anything with an x. Okay, so the variable terms are going to be 9x. What else? 16x and negative x. And if it's negative x, right, we can put a 1 in front of it. Negative x means negative 1x. Okay, let's cross those out now that we've used them so they don't confuse us anymore. So the constant terms, the ones that we have left, are negative 2, positive 8, and positive 10. And did we get them all? Negative 2, positive 8, positive 10. Yep. Okay, so there's one other vocab word here. A coefficient is the number that's next to the variable. So it's the number that's in front of the variable. So instead of 9x, the coefficient of 9x is 9. The coefficient of 16x is 16. And the coefficient of negative x, or negative 1x, would be negative 1. And why is that important? Because that's what we combine when we're combining like terms. So the next part of your notes is just practice separating all of the terms. So I'll do the odd problems and you guys can do the even problems. Number 1, we have an 8a. I'll draw a box around it because it's a variable term. A positive 2a, another variable term. And my constant, negative 3, right? That's the term without the a. So I'll go ahead and write my variable terms, 8a and 2a. My constant was what I circled, negative 3. And my coefficients are the numbers in front of my variable terms, which are 8 and 2. Okay, so don't get too confused with number 2. Don't forget I'm leaving you to do all the even ones. If there isn't anything in front of the x, put a 1 so you can tell what you need to do with the coefficients. Okay, so number 3, I'll draw a box around my variable terms, and I'm including the sign in front. Oops, that's not it. Negative 6. Negative 10 is a constant. I have negative 19a, positive 6a. Oh, and then look at this. I have another variable here, positive 2b. Okay, so that's interesting. I have negative 19a, 6a, and I also have 2b, which is still a variable term. It's just a different variable. My constant is what I circled, negative 10. And then I have my coefficients, which are negative 19, 6, and then, of course, my 2. Okay, so hopefully you're getting the hang of these. They throw extra variables in there to try to make it scary, but don't be scared. Number 5, we have positive 1xy, right? If there's nothing in front of the variable, put a 1. And negative 2xy. Okay, so those are my variable terms. Okay, So my coefficients are what I didn't put a box around. Sorry, I keep on getting coefficient and constant mixed up. My constant terms are what I didn't put up my box around, which are -12 and +9. And here we go. My coefficients, which are the numbers in front of my variables, would be +1 and -2. Okay. Number 7. You guys can go ahead and do it with me. We'll put a box around the variables and the sign in front of the variables. Okay, so my variable terms are -1y, 7y, and 2y. My constant terms are -6, -10, and then of course my coefficients are going to be -1, 7, and 2. All right, one more of these. 6n is a variable term. 1n is a variable term. Okay, look, we have this -3y because I want to switch it up. So 6n, 1n, and 3y. And this time, my only constant, the only thing left, is -25. And my coefficients will be 6, 1, and 3. Okay, so if you need to pause the video to do number 2, 4, 6, 8, and 10, please do so. Otherwise, you can keep watching the video and come back to it later. All right, so combining like terms. You can simplify an algebraic expression by combining like terms. This means you combine common variable terms and constant terms. Okay, so the box trick works for me, so that's what I think I'll do. I have a 9x, I have a positive 16x, and a negative x, which I know means -1x. Okay, and then all of my constant terms I'll circle: -2, +8, +10. So we'll combine the variable terms. 9x plus 16x is 25x, minus 1x would be 24x. Okay, and the constants, my -2, my +8, and my +10, I'm going to do the 10 plus 8 first, which is 18, and then add in the -2, which is the same thing as -2, so that is a positive 16. Okay, so I guess I'll do the same thing where I do the odds, and you can do the evens. Looks like we have 4p, 8p, and 10. So this one's not too bad. I have my 4p, my positive 8p, and my 10 is the constant. So that one stays out. We don't combine it. 4p plus 8p is 12p, and the 10 we just drop down. Okay, so number 13, don't forget if there's nothing in front, I'll put a 1. I have 1a minus 4a is -3a, right? Those are different signs. So I subtract and keep the sign of the bigger number, that's the 4. And then I also have the -7 and the +2. -7 plus 2 is -5. Okay, number 15, we have 1x, right? I'll put a 1. 1x plus 4x minus 8x. Those are my variable terms. So 1x plus 4x is 5x minus 8x is negative 3x. And then that positive 4, the constant, it just drops down as is, plus 4. Number 17, 10b plus 7 plus b minus 14. So I'll draw a box around my variable terms. That's 10b plus b, which I know is 1b, is 11b. And 7 minus 14 is negative 7. All right, number 19. They throw in some extra variables in here, so I'll draw a box around my a values and an orange box around my b values. Guess they're trying to confuse us. And I'll leave the constants unboxed. I have 6a plus 5a is 11a minus 2b. Well, that can't be combined with a, so I'll just write it as is, minus 2b. And then I have my constant values, negative 9 and 7. And 7 minus 9 is negative 2. Okay, so they're really trying to change it up, but don't let it get confusing. Here we have in 21, we have negative 6x minus 11x. So negative 6x minus 11x is negative 17x. And my constant, negative 12 plus 5 plus 3. Well, I know 5 plus 3 is 8. So negative 12 plus 8 is negative 4. Okay. Oh, look at number 23. That's funny. I have 4 variable terms, no constants. I have a minus 3b plus 5c plus 4a. So hopefully you can see that the only thing that can be combined is my 1a and my 4a. My 1a and 4a makes 5a. The rest of the problem, minus 3b, stays minus 3b. Plus 5c stays plus 5c. So what can we combine in number 25? We have 10d plus 5f minus 14d plus 5 minus 12. Well, we have 2 terms that have a d. So we have 10d minus 14d. We can combine those. And then we also have our constant terms, the 5 minus 12, right? So we'll just put these in alphabetical order. 10d minus 14d is negative 4d. And plus 5f stays plus 5f. And 5 minus 12 is negative 7. Okay, so that was the first page of your notes. Hopefully you're not too overwhelmed. The second part of your notes, page 2, is review. So go ahead and flip your paper over, and we're going to review the distributive property. Okay, so we covered this in Bell Work for last week. Now, we did 1 week of distributive property, and you had it in your test on Friday. So hopefully it doesn't seem too hard. Distributive property states that if you have A times the quantity B plus C, it can be rewritten as A times B plus A times C. So essentially, I know it sounds confusing when you're just using letters. You multiply the A to the B, right? That's A times B. And you multiply the A to the C, which is A times C. Okay, so if you have A times quantity B minus C, that would be AB minus AC. All right, so I know that sounds a lot harder than what we did in class, but let's go ahead and do the guided examples. 4 times quantity x plus 5. Multiply 4 times x, 4x, and 4 times 5, which is 20. Sorry, guys. So here, number 2, we have 6 times 12, which is 72, and 6 times x. It's actually 6 times negative x, which is negative 6x. Okay, and we know that in math we like the variable first. So I'll go ahead and switch this around so that it says negative 6x plus 72. Okay, but both answers are correct. All right, so number 3, we're distributing negative 7 times 2x. Negative 7 times 2x is negative 14x. And negative 7 times positive 3 is negative 21. Okay, so don't get too confused with those double negatives here. Number 4, negative 2 times negative 4x. What's negative times negative? That's positive 8x. Okay, negative 2 times negative 11. Negative times negative is positive, so that's positive 22. Okay, so we have lots of practice here. I'm going to do 7 on. I'll save you a couple of the challenging ones, and you guys can do the ones that I skip. So number 7, we have to distribute 2. It's negative 2 minus 9n. So we'll do 2 times negative 2, which is negative 4. 2 times 9n, and it's negative, so that's negative 18n. Okay, and don't forget we like the variable first, so we'll write that as negative 18n minus 4. Okay, number 8. Negative 4 times negative 4. That's positive 16. Negative 4 times positive 6a. Negative times positive is negative. So that's negative 24a. And rewriting that, I know that the 16 is positive, so I have negative 24a plus 16. How about number 9? Number 9, we're distributing the 3. 3 times 1, well, that's easy. How about 3 times negative 6y? Negative 18y. And switching that around, that's a negative 18y. We'll write it down as is. And a positive 3, so plus 3. Number 10. Negative 4 times negative 7. That's positive 28. Oh, look, negative 4 times negative 7x. That's positive 28x. And negative 4 times positive 2w is negative 8w. All right, I kind of like that one. We'll look at number 11. We're distributing a minus sign. What does that minus sign mean? So negative in front of the parentheses is the same thing as negative 1 times p minus 5r. So if we're distributing negative 1, right, that's negative times p, or negative 1 times p, is negative 1p, which is still just negative p. And negative times negative 5r, well, that's a double negative. Negative 1 times negative 5 is positive 5r. Okay, so I want to show you how to do the fraction ones. I'm going to do number 14 and 15 and leave you 13 and 12. So if we are multiplying 3/4 times 12, okay, you can come to the side and do 3/4 times 12 over 1, right, and simplify as you go. So 12 divided by 4 is 3, and I know that's 9x. Okay, and 3/4 of 4, 3/4 of 4 over 1 is 3. So that's 9x minus 3. All right, now there is a trick. Okay, so I like to say, what is 12 divided by 4 times 3. 12 divided by 4 is 3 times 3 is 9. Okay, so we can do the same thing with the 4, right? 4 divided by 4, 1 times 3 is 3. So that's my trick. And you're welcome to use my trick or you're welcome to write it out. It's up to you. So if I use the trick for number 15, 9 divided by 3, 9 divided by 3 is 3 times 2. So 3 times 2 is 6, and that's negative 6x, right? We don't lose that negative sign. It's still there, okay? And just to prove it to you, I'll come over to the side and do 2/3 times 9 over 1, right? It's the same thing. If I reduce 9 divided by 3 and make it a 3, 2 times 3 is 6. Okay, so that's negative 6x. 12 divided by 3 times 2 is 8. So 12 divided by 3 times 2 is 8, and it's negative. Negative 6x minus 8. That's my fraction trick, and you can use it for number 13. Okay, so that's it on the notes. You guys are in charge of doing all the problems that I skipped. That should keep you pretty busy today. And then use your partner to do the riddle. What does a cow use to cut the grass? So if you're an e-learner, go ahead and choose one side to do. And if you're an in-class student, you find a partner. One person does the letter side, the other person does the number side. All right, and then use the answers that correspond to solve the riddle. And I know it's not the first riddle we've done this year, so you should be able to handle that. And good luck. I hope you have a great day. Bye.